should have lots of time to do some questions afterward. And again, this should help you. So when we're talking about the expansion piece, this piece here, so expanding when we get here, that's like the completing the square stuff, right? That's what it would have happened if, or no, the optimization questions, where you came up, if this was your revenue, this could have been like your number of something, and this could have been your dollar statement, right? And then we used expansion to get the trinomial to complete the square on it. That's what we did, right? So this will be a little bit of review, the expansion piece. Okay, but first let's go through the blanks here. So ultimately what I want you guys to get out of today is like distinguish the purpose of and the difference between factoring and expanding. Okay, so very similar. There's similar processes in the sense that they flip you between two forms of a quadratic, right? So you can see like this one's kind of looks like if I wrote y here, that looks like a factored form. Like you could read off the roots from that. What expansion does is put you back into y equals x squared, ax squared plus bx plus c, right? They're opposite processes. That's what I want you to get out of today, right? So then you're like, you want to look at how do you do that? Okay, well then you want to be able to perform the expansion method using one of the three methods, which I'll show you all three. You can pick which one you want to do. And then factor the greatest common factor, factor simple trinomials, which we won't get to. That'll be tomorrow. And then we can check our answers too. Okay. Okay, so in the blanks here, expansion is going to be the process in which we take two polynomials, right? They could be, remember a polynomial could be anything from like 2 terms to 4 terms, right? 5, 6, 7, right? We're just going to take some polynomial and we're going to multiply them together to create one new polynomial. Okay? And then typically when we're dealing with quadratics in general, a quadratic typically takes on the form x squared. So the highest degree or the degree of any quadratic is going to be 2, right? So if the degree is 2, then typically we're dealing with trinomials, right? So that's what goes in this blank here. Right? So that's a trinomial is just something with 3 terms in it, right? So it's x squared plus x plus a number or something, right? Typically. That makes sense so far? So I'll do this question in 3 ways. Since I've left a little bit more space with A relative to B and C. I just want to show you all 3, right? So let's one I showed you one the other day, but let's start with just the FOIL, right? So this will be I'll do everything. The first way I'll do on black and then I'll change the colors. Okay, so the way this works is like you've got firsts, outers, inners, and lasts. Okay, so these are like easy marks. You get to pick which of the color methods you want to do, right? So we'll do the first one in black and then you can kind of pick what goes on, right? So with the first we're identifying as being 7x, and we're going to multiply 7x by the first of the second that's there, right? Okay, so that we're talking about the first in the 2 pieces that are sitting there, right? 7x times 5x. And then we've got the outers, so that's going to be 7x, the 2 pieces on the end, right? We have 7x, and I'm going to have positive 1. That's here and here, right? And then I'm going to do the next one. Inners is going to be the 2 pieces on the inside, so I'm going to take negative 2, and I'm going to multiply it by 5x, right? And then obviously the last, and then the last one is going to be the last, right? So the pieces on the end, okay? The lasts. And so I'm going to get negative 2 multiplied by 1. Okay. And then so that's going to turn into 35x squared. That's going to turn into 7x. Right? This is going to turn into negative 10x. And this is going to turn into negative 2. Okay. And then your only job is to you could just rewrite all 4 of these things here in a line and then collect the two terms that are in the middle, or anything that looks similar, you're going to collect and add together, right? So I'll do that. I'll go 35x squared plus 7x minus 10x minus 2. And I see that there's two things right in the middle that I can add together because they both have, there's just x's. So I can go, okay, well, it's 35x, I'm going to get rid of this here. 35x squared positive 7 minus 10 is going to be minus 3x minus 2. Okay. Is everybody okay? So that's the answer I should expect to get with the other two methods that I show you. Okay.
So whenever you say like expand, you just do one of the three methods?
One of the three, whichever one you prefer, whatever one you like. Sometimes, like, there's one for me that I find the fastest. The fastest one is possible to make a little couple of errors, which I'll do the fast one next. You can see the contrast between the two, and then I have the third one that I kind of like, which is the table, which I showed you guys the other day. Okay, so as long as everybody's okay with that, so that's called FOIL, right? This method of FOIL. First inners, outers, last. Okay, the second method, I'll do in red. I call this the it's the shortest. It has the least amount of work associated with it. Okay. We'll call this. This kind of get called the rainbow. Right. The rainbow is like very similar to FOIL, except I draw 4 arches. Right. So I kind of go, okay, this one times that one, that times that, right, and then I get that times that, and that times that. It's very similar to FOIL. FOIL just adds contextualizes which ones you're multiplying together. So the F is the first and whatnot, right? I'm just drawing the connection, and I'm making sure that all 4 of them are connected in some way, right? Okay, so then I'm just going to go, okay, I'm going to follow the first arch, which is the 7x times 5x. So that's going to be 35x squared. And then I follow this. I also go back to the 7. I do 7x. I follow the top arch. 7x times 1. That's going to be plus 7x. Negative 2 minus 10x. It's going to be negative 10x. And then negative 2 times 1 is going to be negative 2. Okay, and then again, you just collect the 2 in the middle, right? You can see how short that one is. It's nice, right? The problem is that sometimes you can make sign errors a little bit easily with that because it's not visually organized and like the FOIL is, right? It's not so discrete in the way that it's organized. It's kind of it's easy to make a sign error, and then you get the wrong trinomial. You factor the wrong trinomial, you get the wrong answers, that sort of thing, right? You see how like if this was an optimization question and I did the expansion wrong, I'm going to get the wrong vertex. I'm going to get the wrong answer, right? So it's up to you which one. You could bounce between the 3 methods, right, and make sure that you're okay doing it. Right? So it's 35x squared minus 3x minus 2. That's good. Okay. The last method I call the table method. This is a common. This is how I kind of did this in the 2P. Okay. And we draw a table, right, which we did the other day. And the table basically represents the area, and the area is going to be the trinomial itself. Okay. So with this one, I'm going to break this up. And basically with an area equals length times width. The length is going to be, I'm going to get rid of these arches now because we're done with this. The length is going to be this piece here, and the width is going to be this. So I write them on top and side, right? So I'm just going to go, okay, first piece is 7x minus 2. Okay, Along the side, I'm going to get 5x plus 1. Okay. And then I know area is equal to the length times width, so I'm just going to multiply the length times the width. So I'm going to go 5x times 7x is 35x squared. 5x times negative 2 is negative 10x. 1 times 7x is going to be 7x. And then 1 times negative 2 is negative 2. And then you can just clean up the inside, right? So again, just collect the like terms that are in there. Okay, so you can see I got the same answer all 3 times, so I know I'm good. Not that you have to do that every single time. You're not going to, right? See how tedious that is. But you get to pick the method if you want the black, red, or green, whichever one you want, right? And use it. And once you get the hang of it, I would maybe gravitate towards the red method because it's the fastest, right? But if you need to start at the black or the green, start there and then work your way to the rainbow method because you can see how little work that is. Okay? Is everybody okay? So we can just do this now, okay? And it doesn't matter how complicated what goes on down here. It's just everything has to get multiplied by everything in each of the pieces, okay? So for the purposes of this and trying to get through and let you guys get some work done, all rainbow, so it's like fast, right? But there's no saying that when you do your work, you can't pick one of the methods, okay? So this is going to be 2x times 3x is going to be 6x squared. 2x times negative 5 is going to be negative 10x. 4 times 3x is going to be positive 12x. And 4 times negative 5 is negative 20. Okay, and then you just collect the pieces in the middle, and then you're good. Negative 10 plus 12 is going to be positive 2x minus 20. Okay. And then Noah, I'm predicting that you were going to ask me about like any factoring involved. We'll do that after, but right now let's just assume that we don't know how to pull out the greatest common factor, and we'll just leave it there. Okay. Typically, you would see there's a 2 common in all 3 of those terms. I could pull the 2 out, right? But that's going to be kind of like the next page. Okay. Are we okay? So the next one. Again, so now I have 3 terms in the second piece there, multiplied by 1 here. So this just gets a little bit more complicated, right? I get 3 arches on my rainbow this time. Okay, so that just means x times x squared is going to be x cubed. X times negative x is going to be negative x squared plus an x. Then you're going to go, okay, I'm on the bottom now. There's my 3 from the top arches. Now I'm starting the bottom arches. It's negative 1, so it's minus x squared. And then negative 1, would be an instance that this might be a little risky to do this method if you weren't keeping track of the sign. I have negative 1 times a negative x, so that just means it becomes positive x. And then negative 1 times positive 1 is negative 1. Okay, so I should have 6 terms there, right? Because I have 2 in the first and 3 in the second, so that should be 6. And then I just clean it up, right? So you could, if you need to write the next step, you can write the step. If you can skip, you can do that too. So I'm just gonna reorganize things into descending order, basically, right? Right. So I just clump everything together, and I get x cubed minus 2x squared plus 2x minus 1. Okay. Any issues? Nobody freaking out yet? Yes?
What about the last one? How is that FOIL? If you're doing X, is front, outside, inside, left?
Yeah, the FOIL kind of breaks down once you start mixing outside of 2 binomials together, right? That's why I show you all 3.
Okay. But aren't they all just FOIL?
They are kind of all, yeah. You could say, okay, I'm going to do, you've got first, you've kind of got, yeah, that one, it still breaks down for that.
Just kind of remember them.
Yeah, that's why I like the rainbow, because you can visually see that You know you have to multiply. There's nothing wrong with the table either. The table will work, except here's your table for this one. It's a good question. Okay. Your table is just a little longer on one of the sides, not a square now, right? So then I'm going to get I got two pieces running down the one side, x and -1. And then across the top, you got your three pieces. You can go x squared, -x, and +1. Right? Now it's a 3 by 2 rectangle this time instead of a 2 by 2. Right? So then I can go x cubed, -x squared, x, -x squared, plus x, -1. So you can see I got the 6 pieces there again, right? So the table, I think the table and the rainbow method are like, they will not break down on you. The foil thing is more meant for ones that look with like this one, with the 2 in it. Okay. Okay, all good. That's basically expansion. If you go to the next page, there's kind of a challenging one, right? It's not really that challenging. It's a little bit challenging, but the challenge kind of comes out of, do I know what this exponent means physically? That's the challenge. So that just physically means that there are 3 of whatever's inside the bracket, much like if this was x cubed, that would be x times x times x, right? This is just becomes x minus 3 times x minus 3 times x minus 3. It's just a little bit more annoying because you got 3 things going on. The table, I would attack this as 2 binomials first, so I would ignore that that's there. I would do the expansion on 2 of them, and then I do the expansion on the third one on top of the other one. Does that make sense? I'll do this, and you can see. So I would initially ignore the orange. Okay, let's just deal with it as if it's a 2, like 2 binomials. Okay, so I could just go, okay, that's going to turn into x times x, x times -3, x times -3, and -3 times -3, right? So that's just going to be x squared minus 3x plus 9, and all that's going to be in a bracket, and that's going to be multiplied against x minus 3. Right. So that x minus 3 is the orange piece. Oops. Right. I'm not worried about that yet. Okay, let's clean up the inside of the one on the left. That's going to turn into x squared -3 minus minus 3. It's going to be -6x plus 9. Now I can take into account the x minus 3, and this turns into the question from the other side, right? Where I could take, and maybe you prefer to write it like this. Maybe I'll move this around. I'll change the order. You guys can, so it looks more normal. You could do this from the beginning. Okay, now it looks like the rest of the questions. Nothing wrong with that. The order in which we multiply things does not matter, right? So I can flip that around. And then I can go, okay, I'll just do the same thing now. I'll do the rainbow in a different color so you can see it. I'll do it on blue. Right? So then I'm going to get x cubed minus 6x squared plus 9x. That takes care of the top arches. And then I'm going to start the bottom ones. Minus 3x squared plus 18x minus 27. And then clean it up. So I'll write the next. I'll clean up all the stuff here. I got x cubed minus 6x squared minus 3x squared plus 9x plus 18x minus 27. So that's me just rewriting the line above, right? Just organizing everything. I'm clumping things that look similar so that I can just do the math in the next step, right? So then the final answer is going to go up here. I'm going to get x cubed. And then I'm going to deal with the negative 6x squared minus 3x squared from right here, right? I'm going to deal with this. That turns out to be negative 9x squared. And then I'm going to deal with this because these two look similar, right? Those condense to 27. And then you have the minus 27 on the end. That's it. A little bit more complicated because there's 3 there. But if you apply your rainbow or your arches, right, it'll just work. That's it for expansion. That's probably as hard as it's going to get. I'm not going to ask you to do a 4 because then you're just going to be like, it's silly. Now, if you take the 3u, if you've sat through the 3u, you learn about this thing called Pascal's triangle. And there's a pattern. There's a pattern to these expansion things as you go down. Yeah, there's this like Pascal's triangle basically looks like this. It's kind of got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So that's Pascal's triangle, and it turns out that these are the coefficients. So if I look at didn't work too well here. Those are the coefficients for what the expansion. You don't need to write that down. That's just fun fact. So I wouldn't. The point is, I wouldn't ask you to do something with 4. Yeah. Okay. Are we okay? That's expansion, right? And you'll have lots of practice. There's lots of practice on the sheet here. Okay. So, what did we look at? We looked at this with the, well, we've had some experience with this with completing the square, right? Because we can't have an a value other than 1 before we complete the square. So we've already had some practice dealing with the first, this like number a, right? So let's pretend for a sec that I don't want to have, or if I could simplify this, I guess that would be the other way to write this. Factor simplify fully. I see that I could pull a 3. If I divided both these terms by 3, I'd write the 3 out front, because that's a set of, I've taken it out and put it out front, and then I have to write the products that are left after I've pulled it out. That's what factoring is, right? So in this case, if I divide 3x by 3, I'm just going to get x. And if I divide 6 by 3, I'm going to get 2. Okay. And then I'll take this opportunity to like show you, okay, and we talked about this a little bit, that if I factor something, if I've done it correctly, I should be able to expand and get the original back, because they're opposite processes, right? So if I put that 3 back in there, I better see that I get 3x plus 6, in which case I do, right? That's that. Then I know I'm right? So 3x plus 6. That's what happens if I put that back in here. That's an easy one. Next one's a little bit more complicated. Well, not really. You will see that like when we factor simple trinomials, though, that's the way we can check. So I get my 2 factors, and if I expand them, I get the original back. Okay. We'll do that more tomorrow, okay? But let's just concentrate. I want you thinking about that as we go through here. If I am ever stuck, you should be able to check whether or not your answer is right, okay? So with this one, 2, 4, and 6 are the coefficients. So it looks like I could pull a factor of 2 out and be okay, right? So I'm going to have 2, and then inside the brackets, I write what's left after I take the 2 out. So if I take the 2 out of the x squared, I just get x squared. If I take it out of the 4x, I'm going to get plus 2x. And if I take it out of the 6, I get plus 3. And just visually, I can see that if I put that 2 back in there, I get my original back. So then I know I'm good. Okay. Next one, little bit different. Subtly different. So I'll use this opportunity to talk about the greatest common factor is not just numbers, right? Right? I see there's two things going on here, right? I see that there's a 5 common in all three of these, right? But then I also see that I can take an x out too. In all three of them, right? So my greatest common factor in this question, if I were to write it off the side, is going to be 5x. So I want to write down all the products, or what's left after I take 5x out. Okay, so we're going to go, okay, 5x is what I'm taking out because that's my greatest common factor. That's what I visually see is in all three of them. And then I write what's left afterward, right? So I'm just going to go, okay, I'm going to get x squared plus 5x plus 2. Everybody okay? Yeah, that's just what's left. So if I look at that again, I can go, okay, well, 5x times x squared is going to be 5x cubed. That's the original. 5x times 5x is going to be 25x squared. And 5x times 2 is going to be the 10x. So then I know I'm good, right? Go move on. It's always good to check because as these things start to get more complicated, particularly E, right? We start mixing multiple variables and sometimes numbers that don't go into all of them or whatever, right? It's always good to like check back into what's going on here, okay? So the next one, what am I pulling out? What's my greatest common factor, if you will? You know, just by visually looking at what we got going on there. Hector, yeah?
2x.
Good. So if I go, okay, I see that there's the biggest thing I can pull out of all three of those things is the 2x, right? Because 4 doesn't go into 6, but 6 goes into 18. That could have worked if I had like 12 or something on the end. Then it would have been 6x or something, right? But 2 is the biggest that I can take out of all of them. So I'm left, okay, 2x, and then I write what's left. Okay, well, I'm just going to go, okay, well, it's 3x cubed minus 9x plus 2. And that should give you the other one back, right? Okay. Last one's a little trickier. Or E is trickier. Okay. What do we see in there? The first thing I would see, I always think, okay, I see numbers and I see variables. I do two different things. And I'm like, okay, well, when I write my GCF here, like greatest common factor, let's look at the numbers. What's the number that's going to take out of all three of those? Hector?
3, but negative 3, it's hard to know because there's a negative.
I don't think there's any, unless we're completing the square, right? You don't want anything in front of x squared, in which case you'd pull the negative out with it. You got to look at the circumstances, right? Not wrong, right or wrong here, whether or not you left the negative or took the negative. For good practice, I might just take the negative because they throw wrenches in things sometimes, right? So let's say the number I'm taking out is the negative 3. And then I also see I can take out an xy from all three of those, right? Because I see it in all three of them, right? Okay. So then my greatest common factor is going to be negative 3xy. So then I'm going to go, okay, well, I know I have to take this out. What's left after I've taken it out? Okay, well, negative 3x squared y cubed divided by negative 3xy is going to be x y squared. Right? Next one's going to be, okay, take the 3 out of the 15. That's going to be negative 3. Sorry, 5. Right? And then if I take the x out, then the x's are gone, right? If I divide this by 3x y, the x's are going to cancel. One of the y's is going to cancel with one of the y's, so you're just left with 5y. All right? Okay? And then the last thing you got to figure out is the 27. Well, if I take negative 3 out of 27, let's do that. So divide this by negative 3 xy. 27 divided by, or negative 27 divided by negative 3 is going to be positive 9, right? X's cancel with the x's, and the y's cancel with the y's. Yeah, no.
Why are X and Y
In outside, because they got it. So anytime you have a greatest common factor, you got two pieces, right? I've got a number that I can see in all three pieces, right? But then I'm like, okay, well, greatest common factors aren't just numbers. They're like, I can take out anything, they're common, whatever's common, right? So I'm like, okay, well, what else is common in there? Well, I see some x's and y's, the variables. And how many, I'm going to get rid of this. I'm going to erase this here, clean it up. Okay, then you're like, okay, you got to look at like, how many of them can I take out? I can only go as low as I can go low, right? Like I can't go any higher than whatever the lowest amount is there, right? So I see there's an xy there, I could take that out of all three as well. So then you're like, this is where it gets complicated, but then you're thinking, okay, well, did I do this right? I have no idea. So you got to look, okay, well, if I put the negative 3xy back in, am I going to get what I had in the original back? Right? So if I look at that, I'll do it underneath to clean it up. So negative 3xy times xy squared, that looks like it's going to give me this back. Right? Because negative 3 times the 1 that's sitting here is going to be negative 3. That takes care of this. X times x gives me x squared. That's good. And the y times the y squared is y cubed. That's good too. Right? I'm good. That term's good. So I did that one right. Then if I look at the next one, right? We'll do it again. Negative 3 times negative 5 should be positive 15. That looks good. X times, well, this. I just need one x there. That's good. And then the y times the y should be y squared. And these do the same thing. This one's easy because I need it to be negative 27. If I check the negative 3 with the positive 9, that gives me negative 27. And then the x, y just come tack themselves onto the ends. Then we're good. Okay? Everybody okay? Okay, one more, and that's it. A little bit different this time, but surprisingly common as we start doing some more stuff in this unit in particular. Yes, Hector, do we know what we're doing with this one? Sorry, I thought your hand was up. Okay. Okay. So originally I might think, okay, well, I'm just going to look at that statement, right? I'm going to go, okay. Just look at it for a minute, and then I'm going to go, okay, I got three terms going on here. I got the first one, and it's separated with a plus sign. I got the second one, and it's separated with from the third one with a minus sign. Right? So then I'm asking myself, okay, well, I've got 1, 2, 3, right? What do I see in all three of those pieces that's common? That's all I'm asking myself, right? Doesn't have to be a number, doesn't have to be a variable. It could be like you're just looking at like what visually is there in all three pieces. Right? So when I look at this, I'm like reading left to right. 4x. Normally I would look at the coefficients, right? But I'm like, there's nothing going on here between 4x, 5y, and negative 3. It's not there. There's nothing common, right? So then I'm like, okay, well, I'll shift my attention to the other halves, right? Okay, well, I see a w plus 1, and a w plus 1. So I'm like, oh, there it is, right? Your three pieces that are in common. So your GCF here is actually W plus 1. Right? So then you're just going to go, okay, well, I'm going to take W plus 1 out and write what's left after I take it out. 4x plus 5y minus 3. Done. That's common. You'll see that. You'll see that when we do a little bit more factoring, more complicated factoring examples. That's all that's common, right?
But if you put W plus 1 back in, wouldn't it not work the way that we've been taught?
What, like this?
No, like, because if you multiplied it back through to check your answer.
What, individually? Like this?
Yeah.
We could do that if you wanted.
But wouldn't you end up with 4x W?
Yeah. Wouldn't you also get that if you expanded it here?
Right. You're right. Yep.
So they've done this strategically because sometimes it's like, if you expand this in, right? If you expand this in here, you're going to get this really long statement that looks like a mess, and I don't think you're necessarily going to get any like terms. It's just you're just going to have 1, 2, 3, 4, 5, 6 terms, right? Then you're like, oh, well, there's nothing in common, so this has just got messier. And you can't see the W plus 1 anymore. Yeah, Noah. No, it's just in all three pieces. So let's go back to a basic. There was no power of 2 here, right? Because it was buried in both those. So I just took it out. Right, so maybe not the best example, but what about like I didn't put a cubed here, right? That makes sense. Okay, everybody okay? So remember, it's just like to tie it together here. We just want to make sure that we can expand, right? And then we can like actually perform the expansion using one of the methods. You get to pick which one, and then factoring it. The most important part of that is just identifying what that greatest common factor is, right? And that's it, right? And then you can always check your answers by doing the opposite process. Does that make sense? And at the end of this, I'll give you a flow chart that shows you everything, like what the process is going from each of the 3 forms, right? That's it. Okay.